In this video, we're going to take a look at how we can use systems of equations and inequalities to help us solve different problems. So basically, the only new thing here is that we need to be able to read a question and figure out what the system would be. Then we'll use any of the strategies that we've learned so far to solve that system. And for these, we're usually not going to specify using substitution or elimination, so you're going to be able to choose which method you would prefer to use. The first step anytime we read a question is that we're going to define our variables. So it's going to be really important that we state what those variables represent, so that at the end, when it's time to give our answer, we make sure we give the correct numbers for the correct labels and answers, things like that. Next, we're going to see how the information in the problem is related and use that to write a system of equations or inequalities. Then we'll solve the system, and then we'll answer whatever question was asked. So again, it's important that we read carefully so that we know what's going on. So if I look at this first question here, it says our family is planning a 7-day trip to Florida. You estimate that it will cost $275 per day in Tampa and $400 per day in Orlando. Your total budget for the 7 days is $2,300. How many days should you spend in each location? So if we look at the important information here, we're going to take a 7-day trip, and based on our estimates, it's going to be $275 a day in Tampa and $400 a day in Orlando. Our question, or actually also, the total budget is $2,300, so we can't spend any more than $2,300. And our goal here is actually going to be to use that full budget. And we want to know how many days should we spend in each location. So the question drives my variables. So that's going to tell me what my variables are. I'm just going to use X and Y, but you can use whichever variables you prefer. And I'm going to make X the number of days that we spend in Tampa, and Y the number of days in Orlando. So this is that first step, defining our variables. We're saying these are the variables that we're using, and this is what they represent. So now we need to figure out an equation that we can write. Since both of these are days, and I know that I'm taking a 7-day trip, if I add the Tampa days to the Orlando days, that should be equal to 7 days total for my trip. Then we have all this information about cost. So if it's $275 per day in Tampa, the cost of my Tampa time could be represented as 275x. And then $400 per day in Orlando would become 400y. And all of that is equal to my total budget of $2,300. Now we have a system of equations. Again, you get to pick how you solve this. So go ahead, pause the video, and see if you can solve that system. All right, so I chose to use elimination, eliminating x. You could have eliminated y, you could have used substitution, you get to choose. And I found that y equals 3 and x equals 4. So this is where it's important to have your variables defined. If I look here, I saw that y was days in Orlando, so that means I'm going to spend 3 days in Orlando, and x was days in Tampa, so I'm going to spend 4 days in Tampa. Here we're given kind of answer slots that include the label, so we don't need to include any units. But if these were not here, you would want to make sure that you write 4 days in Tampa, 3 days in Orlando. All right, now we're going to look at another question. At Carlo's Bakery in Hoboken, New Jersey, one customer pays $5.67 for 3 bagels and 4 muffins. Another customer pays $6.70 for 5 bagels and 3 muffins. We want to know how much does a single bagel and a single muffin cost. So this is a pretty common systems question that we'll see where we're buying different combinations of items, and those combinations are going to tell us what equations to use. So we have one particular customer who pays $5.67 for 3 bagels and 4 muffins. That's going to be one equation that we use because all of that information goes together. Next, we have $6.70 for 5 bagels and 3 muffins. That's going to be our second equation. And then our question here, how much does a single bagel and a single muffin cost? So that's going to drive my variables. Again, I'm going to use x and y, but you can use whichever variables you want. I'm going to make x the cost of 1 bagel, and I'm going to make y the cost of 1 muffin. You could flip these if you want. It's totally up to you. Your equations will just look a little different. But again, as long as you follow everything through, you'll be good to go. So this first combination is going to be my first equation. I know that 3 bagels, so 3 times the cost of a bagel will give me my cost of those 3 bagels, plus 4 muffins. I used b there instead of x. That's my mistake. So 3x plus 4y is going to be equal to that $5.67. Then my second combination will be 5x for 5 bagels plus 3y for 3 muffins, and that's going to be equal to $6.70. So again, now you have your system. Pause the video and solve it. All right, so I chose to use elimination. I chose to eliminate x via a common multiple of 15. So that gives me a y value of 75 cents, 0.75, which means that one muffin costs 75 cents. And I got an x value of 0.89, which means that one bagel costs 89 cents. Again, here make sure you use units with your answer. And you can also always use Desmos to check your work. Just plug your system in and make sure that your solution matches. All right, next up we have our mixture problem. And this is probably the trickiest of the systems applications that we look at. So here in this question, we have one metal alloy, a mixture of metals, that is 25% copper. So we mixed a whole bunch of stuff together and 25% of that is copper. Another metal alloy is 50% copper. So this one has a little bit more copper in it, 50%. And we're going to combine these alloys, and we want to know how much of each alloy should be used to make 1,000 grams total of an alloy that is 45% copper. So our question here is how much of each alloy, so that tells us that our variables are going to be the amounts of this 25% and this 50%. So I'm going to make x the grams of 25%, and I'm going to make y the grams of 50%. And so now I have two requirements for my new alloy. I have 1,000 grams total, and I have that it should be 45% copper. So if I know I need to have a total of 1,000 grams, that means that if I add the grams of 25% and the grams of 50%, that should give me 1,000 grams total. Next, we need to figure out this percentage of copper. So if I have this 25% alloy, that means that 25% of the grams of that alloy are going to be copper. In other words, 0.25 times the number of grams there will tell me how much copper I have in that particular amount. Likewise, for the 50%, if I do 5/10 times the amount of the 50%, that will tell me how much copper is actually in there. We want to make 1,000 grams of 45% copper. So I need to take 45% of 1,000 to find out how much copper should be in my result. So this equation is going to be 0.25x plus 0.5y equals 450. And this is usually the more challenging equation. This is where you're going to use those percents as coefficients. So 0.25x, 0.5y, and then you're going to take the final amount and the percentage and multiply them together to find the constant in that equation. So now, once again, you have your system. Go ahead and pause and solve. All right, so I chose to use elimination here. I chose to eliminate y using a common multiple of 1, so we multiply the second equation by 2. That eliminated y gave us an x value of 200, so I know that I need 200 grams of 25%. Use the G for grams, write the word out. And then for y, once I substitute back in, I get 800, so I'm going to need 800 grams of the 50%. So with the mixture problems, there are two equations. One for the quantity, so that will be grams, ounces, whatever you're looking at. And then one that handles the amount of whatever you're looking at. So it could be chocolate and chocolate milk. It could be a juice concentrate. In this particular case, it was the amount of copper that we're going to end up with in the equation. So we can also solve problems using systems of inequalities, and our steps are going to be pretty much the same. We're going to start by defining our variables, then we're going to write a system of inequalities, and we're going to have to look for some keywords here that tell us what inequality symbol we're going to use. And then remember, to find the solutions to a system of inequalities, we actually create a graph, so we're going to graph that system. Sometimes we'll do it by hand, sometimes we will use Desmos to help us out. And then usually they're going to ask for a number of combinations that would satisfy that system. And remember that solutions to a system of inequalities lie within that shaded overlap region, so we're going to pick points that are in that solution region. So you would like to see how many baseball games and soccer games you can attend this spring. we know that travel time is 2 hours for baseball games and 1 hour for soccer games. You would like to spend no more than 15 hours traveling, and you would like to attend at least 8 games. We want to figure out how many of each game we can go to. So I'm going to make X the number of baseball games that I can go to, and we'll make Y the number of soccer games that we can go to. Again, you can always flip these, you can use different variables, totally up to you. I'm just going to use X and Y for now. So if we look at the information that we have here, we have our different travel times, and then we have 2 requirements. So our first requirement says that we want to spend no more than 15 hours. So this means I could have exactly 15 hours, or I could have less than 15 hours. So if I want no more than 15, that's going to be less than or equal to 15. So that means that if I add the total number of hours for travel time, that has to be less than or equal to 15. So if I take the baseball travel time, that would be 2 hours per game, so 2x, and I add it to the soccer travel time, 1 hour per game, so 1y, you don't have to include the 1, but I have it in there for transparency right now, that should be less than or equal to 15. So that's going to be our graph, or our inequality here. Then if we look at the second requirement, we would like to attend at least 8 games. So at least means we could have 8 or we could have more. So that means that we're going to use greater than or equal to 8, because we're okay if we go over, we're okay if we're equal, we just don't want to go below. So the total number of games should be greater than or equal to 8. So the number of baseball games plus the number of soccer games must be greater than or equal to 8. So now we want to go ahead and graph that system of inequalities to see where our solutions are. Go ahead and pause the video and create your graph. All right, so when we graph our system here, we see that our overlap is in this region between the 2 lines. So this is where our solutions are going to live. And we can pick any point in that solution region as a possible combination of baseball and soccer game that meets our requirements. So for example, we could say we want to go see 3 baseball games and 1, 2, 3, 4, 5, 6 soccer games. So we could say 3 baseball and 6 soccer. Because that falls in the solution region, that's good to go. Or we could say perhaps that we want to see 5 baseball games and 4 soccer games. And if we look at that point, that also sits right in our solution region. So that would be 5 baseball and 4 soccer. So any point that sits in that green region would be a valid solution for this system.